So if you have been programming in C for a while, you might have come across the idea of a variadic function, which is a function that does not have a predetermined size of arguments. And I learned a few cool tricks for making some projects in C that I want to show you. And this is an example of what we're going to build today. So it's a print statement, but you might notice that it's a bit different from the usual ones, in the sense that there's no format specified. We just put percentages here, and we just specify the arguments. They can be any type. And when we run the code, we get this output. So it automatically finds the type and it knows how to format it into a string. So this is just an example of what we're going to make today. Now, uh, oops, here we go. So one of the problems we have with variadic functions is, as we are reading the data from them, we need to know the type in advance. And what I mean by that is, let's say we have void my variadic function. We have to pass in one mandatory parameter, and then we have these parameters. Then we have my var. What's it called? Test.c. Let's go up. Things, yeah, VA list. So we have this. We have to add. And then what we do is we've got VA start, and then we can use the VA list args and pass in the number of bytes we want to read. So in this case, let's say it's 10. Once we finished using it, we do VA end and then args. So let me just check if that's right, because I might have gotten it wrong. It's VA arg, not VA list. That's why it's not highlighting it. Okay, so here we have VA list, which is the args object we're going to use, and VA start just tells us start reading from. So start reading from this value, which is the first parameter. So start reading data after this, and whenever we want to read data, we have to pass in the number of bytes we want to read to VA arg, and once we're finished, we have to pass in VA end. So the problem with this is we have to know the number of bytes in advance. So if I'm going to have this function and I'm calling it here, so my variadic function, let's say I pass in 10 here, it doesn't really matter, that's the ignore value. But then if I pass in a string here, then I pass in an integer, and then I pass in a float, I need to know that in order to read it here, that is going to be, we're going to pass in a string, then we pass in an integer, finally we pass in a float. If we don't know these values in advance, we won't be able to read them. And also, we need to make sure the user has put in the correct types, because if the types aren't correct and we try to read them in, then we can have some issues and it won't read the values in properly, because each type has a specific size of bytes, sorry, a specific number of bytes you have to read in. So a cool trick I found is, it would be nice if we could somehow know the number of bytes you have to read of the variable in advance. And what I mean by that is, right now this is our string, but it would be nice if we could have some sort of value here. So let's say it's an enum, so we can say it's string first, then it's going to be integer, then we have float, right? So we want to go from this string to this string. And the benefit of having these values here, we can say it's some enum values, is that here, let's say we read in, we know the first value is going to be an enum. So let's say it's going to be size of enum, let's say just say values. We're just going to read in some values here. And then depending upon what we get, so let's say it's string. Actually, don't really need this as an integer, right? So it should be the same size as an integer. We have case of string, then we read in a string. And then I'll just do the same thing for the other two. So we can do something like this, and then int my int, and then float my float. So you can see that if you know the size you have to read in advance before we read the next variable, then we can just we know how many bytes to read forward. And this is a pretty cool technique, but the main question you may have is how can we get this list of parameters into this form? And this is when a cool feature of C is introduced to us. In C11, the generic operator was released, and what the generic operator allows us to do is pass in a value. So let's just say my value, and then we can compare against a bunch of values. So let's say if it's a child pointer, we can just return um we just return 10, sorry 8. If it's an integer, we return 4. If it's a float, we also return 4. So we can do this kind of stuff. So depending upon the type of the value, which is known at compile time, we can give back a value if it matches a certain property, and if it doesn't match the properties, we can just say default, let's say -1, and then this is what we get out. So using the generic attribute and some preprocessor tricks, we can manipulate the argument list from this to this. And I'll just show you how we can do that through the print example I showed at the start of the video. So let's just remove this. And we're going to we have to import some libraries first, right? So you have to do stdlib.h, you have to do stdarg to get the va list functions, va arg, and va end, all those stuff. We get that from stdarg. We need string.h so we can get the length of strings. Mainly, that's the main reason I'm importing it. I import stdbool.h because I like having booleans there. Just makes it a bit easier. And then we need to import this file called map.h. So map.h, it was created by William Swanson. I'll leave a link to the GitHub repo. We can use it. The license is very permissive, so you can use it. But what it basically allows us to do is expand. If I go back, so you see here we can expand these. It allows us to basically expand these arguments into this form. It's kind of hard to explain, but once I start showing you the code, it should make more sense. So we can start writing the code for this print statement, which does not require any format specifiers. The first thing we need is a set of enums. So I'm going to have something called enum variadic type, and also I'm going to import stdint.h because that's going to contain some of the fixed size integers, so like 8-byte integers and 16-byte integers and stuff like that. It's going to have that in there. So we're going to have first variadic end, let's say variadic int 16, variadic uint 16. What I'm basically going to do is type out all the different types we have. Now, fortunately, I got this test code here, which is the one we were using before for the example. I'm just going to quickly copy and paste this because it takes too long. Okay. And then I'll also copy and paste this because I'll explain it. Okay. So this enum contains the different types we have. So we have end, which marks the end of the argument list. We have ints, different sizes, the signed and unsigned versions. We have char, long doubles, double strings, null, and unknown. Unknown is very important. I'll get into why that's important in a minute, but unknown, if we receive an unknown, it means that we can't deduce the type. So it's an unknown type. We haven't considered it in this macro here to get the values. So what this macro does, get type variadic args, it takes in a value and then it just matches it finds out what its type is at compile time, and then we can just get an enum value out of it, and that tells us the number of bytes you have to read to get the variable. And if it doesn't match one of these ones, we go to the default value, which is variadic unknown. And what I usually do is, if we get a variadic unknown, we just return the string at that point, so the string we constructed, because we can't read any more data because you don't know how many bytes to read in front. And we also have to create a macro for this, so we can say define print we're gonna have the format string dot dot dot. That's the underscore VA list of the rest of the arguments, and then we're gonna have example print. Or we can just call it example print. I'm just gonna call it that. We're gonna pass in the format string, and then we pass in map list. This is a macro defined in the map.h header file, and it'll just, what it does is we're gonna give a function here, which is the function is just get type variadic, and then we're gonna pass in variadic, varargs, and then finally variadic end, if you can find it. So what does this line mean? Format string is the format string. So remember before in the example I showed you, I just go to test.c. Here, this is a format string, so we have percentages here. We don't have to give format specifiers, and these percentages represent arguments you have to pass in or you want to place in that area. Map list is going to go through each argument in this argument list, and it's going to run get type variadic and place it before the argument in the argument list. So it's gonna get the value, it's gonna match it. We're gonna find the enum, so the enum value which represents its size, the number of bytes have to read in front, and then it's gonna place it before the argument. And then variadic end just tells us this is the end of the argument list. We can stop passing from there. So let's fill out this function, example print. Let's see. Char pointer example print format string. Then we just pass in these values. Actually, forgot to put the type. This shouldn't be that. It should be void for now. So we have something called VA list args. That's gonna be the arguments you pass in. So we're gonna start reading from them here. Args, and the first argument we have is format string. Now, what I want to do first is split this string or format string into parts. And what I mean by that is, let's say we have, let's go back here, that's it, test.c. We have this string. We have this string, right? What I want to do is create an array which has these different elements. So we have a name, then we have percentage, then we have surname, and then we have another percentage. Then we have age, another percentage, then we have the new line. So I want to split the string into little pieces where the percentages are. And the way we're going to do that is through making an array of strings, obviously, and then we're going to find where the percentages are and then add those percentages there. So we're gonna have char string split into parts, and this part, so we have this char array, so it contains 10 strings maximum, and each string can be around 50 bytes. And then we're going to have an index, which is string split into parts index equal to 0. That just represents that's the first string we're going to put in. And then you can start going through the loop and then just splitting the string into parts. So we're going to go through each element in the loop, and this is why I imported string.h, so we can get string len, string split into parts, then I++. And then if the string at I, so the current character we're iterating over, this is the wrong one, format string. So if the current character is a percentage sign, then we know that we have to split the string. Now, how do we know where did we last split the string from? And what I mean by that is, we need to have some sort of way to calculate where the last cutoff point was. So if we cut off our string here, for example, let's say this is the first one, then we know that we cut from 0 to the current position. But if we cut here, if we're cutting here, then we need to know that we have to cut from this position. So this has to be the index we start the cut from. And the way we do that is creating another variable here called previous index. And this just represents the start cutoff point. And we know that it's going to be at the start it's 0 because it's start the string, but then when we reach a percentage sign, it's going to be the character after that, if there's space. So the way I'll show you how we can do that. So format string first, we have to set it to 0. This just is a normal terminator, so it stops us reading bytes at this position. We can then copy these values into string split into parts, string split into parts index, and we're going to copy the format string plus I. Sorry, not plus I, plus previous index. Now, right now, this is going to be here. We're going to hit the percentage sign here. So it's going to be from 0 to this position. Once we finish here, and then we go to this position here, we're going to set. So after we finish this part, we're going to set previous part's index to be the comma, and the next time we hit a percentage sign right here, we're going to start reading values from this position up to here. So we're going to set format string at I back equal to percentage sign. We're also going to set previous index equal to I plus 1. The reason is I plus 1 and not I because if we set it to I, we're going to start reading values from the percentage sign. So the percentage sign is going to be the first value we read. So we want to avoid that. And we also want to have to increment the string split into parts index variable. The reason I'm adding 2 to it and not 1, as you may think, is because I want to leave holes in the array. So let's say our array was, if you're creating an array of this, wherever there's a percentage sign, I want it to be an empty hole. So it looks something like this. So you get the idea. It's going to look something like this here. And the reason we have this holes here is because we know that a hole represents a place where the argument should be. And if there's a hole, we can just look through the argument list and retrieve the argument and then put it there for when we're going to print the value out. So that's why I did plus equals 2. And yeah. So after we finish looping over all of this, we might have some values at the end which we missed because the array didn't get it at the end. So we might have like a percentage at the end, so we didn't pick up the last value. So in this case here, we might have missed this one because we stopped iterating right here. We stopped iterating before then. Split string split into parts index, and then we're going to do format string plus previous index. So just get the last value you might have missed. So the thing is, we need to know which positions in the string split into parts index is going to contain empty spaces. Now there's two ways we can do that. Either A, every time we want to place a value in, we can iterate over the string split into parts array, find wherever there is an empty string, and then place the argument we're currently on there. Or a smarter way to do it is to create a struct called intArray, and just going to contain an array. Let's say we can do 20 values for now, it doesn't really matter. In practice, this should probably be dynamically allocated, so there should be a pointer here, and then we can do something like, go down here, intArray, and we call it empty indexes, and then we can do something like empty indexes dot array is equal to malloc size of an int times by how many elements we want, so say 50, and then that allows us to reallocate whenever we want to. Or if you've got some custom allocators, you can do it your own way. This is the proper way, but I don't want to be bothered with doing that, so we're just gonna allocated on the heap of 20 ints. So here we have the empty indexes. Whenever we get a value here where we receive a percentage sign, what we can do here is empty indexes dot array at empty indexes dot count, which is the current position we're at. Since we initialize everything to 0 here, so the current count is gonna be 0 at the start, so we can put this as we can just get string split into parts. Index, yeah. I'm going to do minus. Actually, we can do, if you do it here, we can use string split into parts index -1, and then empty indexes dot count plus plus, so we can continue adding values into empty indexes. So now we have to iterate over the different arguments, the argument list. We're gonna have a boolean code finished. You'll see why I have this here. Then we're gonna have char next string. Let's call it 124 characters. Now you'll see why I created empty indexes. And also we're gonna check. Oh, we're not finished iterating over it. Then, if it's a bit confusing right now what I'm doing with the for loop, I'll explain in a minute. I'll just get the code down first. I'm gonna put Variadic end down here. And let's fix the indenting here. Okay, so what I'm doing is we have this args, which is all the argument list, the Variadic argument list, and we're gonna read in an int first, which is the enum values. So here. And once we know, here we got something called, we got a switch case statement, and we're going to use that to find out the type of the variable ahead, so after this enum value, and that will tell us how many bytes we have to read in front, because we can just use size of, but since we already know the type, we can just put the type in directly. And this is also why I've got next string there, and I'll show you what I mean, why I have that there. So we've got next string, and then we can read in a value. So let's just say here we've got int16, we have to use the format specifier HD. We've got vargs, and then we've got int16 underscore t. This is why I got the std, what's it called, std int. That's why I got that. It's got all these specific, it's got this fixed size integers. Once we have that, we can break, and we can fill out the rest with the other arguments. Now, I could do this manually, but I'm not going to because I've got the code written down right here. So I'm just going to copy and paste this. I think it's the whole thing. Okay, we got this, yeah, we got the whole thing here. And then wherever we got next string, we're just going to replace it with next string. I think that's good. It looks good to me. So the format specifiers are different, but since we know the number of bytes we have to read in front, we can just put in the type directly and just adjust the format specifier accordingly. Now, most of them are the same, like double, long double, char, ints. Variadic no is going to be a void pointer. We can't read it. A void pointer is going to be 8 bytes because a pointer is always 8 bytes. On 64-bit systems at least. We're just gonna put in a no value so you can replace whatever you want, but we can't read. We don't know what the value in the void pointer is. It's a void pointer, so just gonna put in no. And this was talking about the variadic unknown. If we got a variadic unknown, we don't know how many bytes to read in front because we can't match it with any other value. So either we can do what I did here, just debug breaks, just panic, or a smarter option might just be we set finish to 2. And when finish is true, so variadic end, we just finish looping. When finish is true, this for loop will just stop iterating once we reach this condition here. So we just reach the end of the for loop. Now what happens when we reach, before we reach the end of the for loop, we have to copy the value of next string into thingy, the split string into empty parts array. So all the empty spaces we had before, we're going to fill those up here. So string split into parts, string split, we're going to use empty indices, sorry, indexes, dot array at I, because we actually are iterating over, as you can see, we're iterating over the count, so that's number of, that tells us the position of the empty spaces in string split into parts. So we're gonna copy that there. I'm just gonna copy the next string. And once we've done that, we kind of filled up the whole array with values. And to show how that works, I'm just gonna print it all out. So we do for int I is equal to 0, I is less than string split into parts index, I plus plus print f, let's say percentage s, new line, string split into parts at I. We know that the current there's going to be no value at string split into parts index because we always increment over it. So if we do print, let's say hello world, then we do a new line, then we do something like good morning. Doesn't make sense, but got a few errors. Let's see, 61. Format string is not defined. Format string. Oh, it worked. Oh, it worked first time. So okay, we've got hello percentage world, and then we've got percentage. So as you can see, it filled in the holes. So we've got hello, good, world, and then we've got morning, which is this value. So now that we have pretty much an array of strings containing the final string that we want, we have to combine it together into one big string. And before I forget, I'm going to free up the args. You have to call it VAN. I'm not sure why, but the specification says you have to call it. It does something, because let's call it final string here. I set to 1054 characters. This is dangerous. You shouldn't be doing this if you're writing proper code you're going to use, but it's fine for now, I guess. For example, why did I remove the code before? We can just use this. And then we can have char final string again, 1024. We can use strcat to be able to concatenate onto the string, so we use string split into parts at I. And then we can just printf this string. Or if you want, we can printf here, or you can just return the value. If you're going to return the value, then you can change this from being you have to change this to be a child pointer. And also, if you're returning a value, then make sure this is allocated on the heap, because if it's allocated in the stack, when you return it, the stack's going to reset the pointer, and then if you make any variables here, you can just overwrite the values there. So you can have something like your data will be corrupted. So we can just do this, we add a new line, and we're just going to put final string here. So if we do this again, let's find it. Oh, we've got hello good world morning. Let's give something decent. Let's say name, surname. Actually, let's do first name. Surname. Then we can have after that age. 20. Let's say 19. Okay, so we got this, right? It detected the types for us. If you add a decimal here, we'll find out it's a float, and then it can do with that. It can do that. If you want, we can also. So if I search for percentage f, a cool trick that I learned is we can do percentage true.f, and that will. No, that's wrong. Yeah, here we go. I think it's this. Yeah, so it's gonna round it to two decimal places. So if I did something like 195923, it would just round it to two decimal places, which is pretty nice. And thank you guys for watching. I hope this was informative and it helped you understand some cool things you can use for debugging stuff or just logging values and structs in general. The code in the description, the map macro is also in the description. I've linked to that, the GitHub repo. And you can also check out some of my older videos, which is about Python. You might be interested in that as well. So thank you for watching, and I hope you have a good day.